You can use bitmake layers, add layer. There's how you add a layer specifically. That'll actually put that where at the very bottom of your bblayers.com, and so that it can be picked up and seen. So let's talk about building our new recipe. We've created a recipe, we've created a layer, we've got all the things set up that we want to deal with. Now we want to build our example 01BB recipe. You can see that it'll be found in meta YPDD recipes example itself, and this recipe's example is a type. That's not necessarily that it has to match example. It could be recipes core, it could be recipes kernel. And if you have a specific recipe for a particular version, I'm going to, Linux Yocto, and then you have a BB append here for Linux Yocto. So that's your recipe file, and that's the path that it would normally be at. That's the pattern it will follow, if you will. All right. There are going to be, if you try and actually use this, you'll find that it has some problems because this recipe has an actual QA issue based on the way it was built. So there are some issues with regard to that. One of the reasons why there is a QA issue is because this one is a C file only style, and you haven't told it where to find certain things. The makefile style or the autotool style will both find your appropriate libraries and find your appropriate LD flags and C flags, because they're already set usually in the makefile, or they're set in the autotooling package, goes ahead and sets those for you. But in the example we're using here, which is a single C file, there are some potential issues with that, and you'll have to add some additional pieces to the recipe in order to make it actually do that. You'll find some OE extra make, and you'll find some compile features that you'll have to add directly yourself. Any questions on any of that before I move on? Okay. So let's talk a little bit about images themselves. Right now, before we were talking about individual recipes. Those recipes may be an image recipe, they may be a single package, they may be a library that emits 4 or 5 different packages in order to satisfy requirements for things like libgettext and some other pieces, things like that. They emit more than one package. But for now, we're going to talk specifically about images and specifically image recipes here. They build the entire system itself. Generally speaking, they create an entire Linux distribution from source. They have to build the compiler, the tools, and the libraries. They know about how to deal with the bootloader and the kernel pieces, all of the base OS, whatever services you want, and whatever applications that write on top of that. So it'll build all of those in one go. Now, at this point, you're going to end up having something that you can, depending on whether you're using QEMU or perhaps you're using something that's going to go on a target, then there's an additional step which would have to be done if you're going to put it on a target. And then in that, you would actually use the image creation tool called WIC in order to actually take the root file system, the bootloader, the kernel, put it in the appropriate places on the SD card that you're going to put into the device. Go ahead and program up that SD card for you. You unmount that, you go ahead and plug it into your device, and it should boot up at that particular point. There's a whole bunch of options, a whole bunch of pieces and steps, which I haven't talked about in this. I recognize that. This is, again, a beginning class, and generally speaking, if you use it on some of the existing targets, for example, the BeagleBone Black or on the Edge router or any of those kind of things, that will all we have actual image creation files or Kickstarter files. If anybody's familiar with Kickstarter, Kickstarter is a way of creating images on file systems, including the base pieces of the file systems, how big they are, what type they are, all of those things. And then finally, what is going to go in each one of those partitions. Any questions on any of that? Yeah, netboot's all part of the bootloader. Yeah, there's some netboot pieces that we talk about. That's a little bit off topic for here, but yes, netboot is supported. I've seen that before and used it. If you're talking about the netboot that you get out of U-boot, yes, we support that fully. As a matter of fact, when I teach this, often I teach it by using all of my devices. Yes. Somebody who just joined, Sergio, could you mute, please? Thank you. Thank you, sir. When I teach it, I actually do NFS boots and NFS routes. That makes life a lot easier. Did that answer your question, Marcos? Okay. Daniel, Debian is not a source-based system. It produces binaries and delivers binary packages, whereas Yocto creates images directly from the source code itself. The rootfs could be very similar. The choices in which Debian and Yocto differ have to do with who was developing it. Debian has a specific set of guidelines that they build software with, that they build their packages with. Yocto has a different set of criteria for deciding which libraries it's going to put in, which versions of tools it's going to put in, which kernel it's going to put in. All of those things are policy changes, and they differ based on what the objectives are of the group. Okay. Good. All right. You don't have to tell it by default. It depends on the machine. It depends on the machine, Christoph, as to whether or not it's in the rootfs or in the boot partition. Most of the time I see it in the boot partition. You may not even have to, you may not actually have to have a boot partition. You can look straight into the rootfs, in the /boot directory of the rootfs itself. So, okay. I don't. Abdallah, can you explain a little bit more what you're asking about the distinguish between what's included in the distro versus image? In images, are you talking about the image recipe, or are you talking about distro policy? There's a little bit of a difference between those two. You know, image recipe. Okay. Well, we'll talk a little bit about what that is. Normally, an image recipe contains a group of package groups. I need package groups that do a particular thing, like we want the base package that contains certain things. And I want recipes. I want a package group that includes all of the NFS utils or different whatever pieces that you need. And so package groups are groups of packages. If you're familiar with the meta packages that are within Debian or Ubuntu, to where that let's say you want to get you would want to get Chromium, for example. To get Chromium, you'd say apt install Chromium. That is a meta package that sits there and goes and gets the latest version of Chromium that's supported, along with all the utilities and all the other pieces and libraries that make up Chromium. So it's a meta package. In the case of an image recipe, it's calling package groups. Those package groups build other packages as part of a group. It's like a collection, if you will, of packages that are going to be built. Does that answer your question? Zayed, can you explain a little bit more about what you want as far as that specific configuration goes? Right. The bootloader shouldn't really care about libc versus glibc at all, because the bootloader itself, Olive, is before the operating system is running. Generally, the bootloader itself is, doesn't have any library support in it at all. It's all built as a static image. So it really doesn't matter whether it's musl or glibc as far as the bootloader goes, because that's before the kernel is actually running and the user space is running. Hopefully that answered your question, Olive. You can specify what source code you want to use based upon the source URI that we saw in the earlier examples that Bian showed you. You can get a specific version. Let's say, for example, you are getting something from Git. You can check out a particular branch if you want to, so you can get the develop branch if you want to. You don't necessarily have to use the mainline branch. Right. So hopefully that answers your question. So specific images you can include as you can do a BB append, for example, that appends it if you want to, Zayed, as well. If you want to do that for specific images and you only include that specific one. And that BB append would then do that BB append would be in your layer and would only apply when your layer is applied. So it would actually modify what the source code is going to come from. For example, you can check out, let's say you wanted to use the source code from a specific branch, it's of Git, or getting a particular version of it. You can get all of that by doing a BB append, which would modify the normal file. There's also some other preferred provider things where you could create your own recipe that has a particular version number. Let's say, for example, normally they want to build 419 and your board, for whatever reason, only supports 416. You can go ahead and create your own. You can go ahead and create your own version of it that's 416 and say, okay, I'm going to use that one as the preferred provider. We can talk a little bit about that. The preferred provider can be in the configuration step. It's usually in your local.conf that would actually make it so that you get the particular version that you want. You're welcome. Yep, Wendell, that's correct. It's bare metal program. It requires the bare metal compiler and has no library support for it. That's correct. Doesn't know anything about the OS at all. That's correct. All right. Anything else? I don't know. Come back to the site afterwards. They're good. Right now it's on YouTube. It's going to go ahead, or rather, it's being recorded to Zoom, and we'll take it from Zoom and we'll go ahead and get it edited down. And at that point, it'll be available afterwards. I don't know exactly what the URLs are going to be. That'll be done by the volunteers who will go ahead and do the editing of this and then get it prepared to go up. So as soon as we know, it'll be posted. All right. If there's nothing else, I'll move on. You're welcome. All right. Often you do need to create your own recipe in order to add all these new packages and functionality. It's pretty easy that we try and say, go ahead and do a BB append or inherit a class. The simplest way to create this is to inherit the core image BB class. By doing that, you actually use the method by which it creates actual core images that we provide as part of the meta. To add packages to an image, you add them using the image install variable. You'd set the image install variable. You always use plus equals. You'll notice here, this is the image install. This is the basic install. In this particular case, it's package group core boot. That's core image minimal, essentially. I think it's even smaller than that. I think this might even be core image tiny. I want to go ahead and additionally add psplash and drop bear. You'll notice that we use a plus equals, otherwise it will overwrite this, and the only thing it'll build is p slash and drop bear. You want to make sure that you go ahead and build that first, and then add these additional features that you want. These are the new desired packages to add to it. You're inheriting core image so that it understands how to turn that into a nice little core image. You'll see that they've also added an option for the size of it to be 8 gigs, so that it nicely fits in a particular SD card or in a particular flash partition. Remember, a lot of these are going to go on to some kind of a flash device on the actual device itself. All right. So we're going to talk about enabling our meta YPDD layer. You can edit conf bblayers.conf, or my preference would be to go ahead and use the bitbake layers -add layer. It'll go ahead and make your life a lot easier. Okay. You can add it manually here. Again, that path may be outside of where you think it is. You'll notice in this particular case, we're looking in Pocky for these, and we're looking in our build directory for existing meta YPDD. I believe that's his default, Roberto. And if you guys would hold, yeah, go ahead. That's correct. I'm sorry. Yes, you can limit the size to be larger. Absolutely. Absolutely. Normally, I don't see that used. It only is done often to make sure that the files are actually going to fit in the image, and that you don't end up with an image size that's larger than the partition that you have available to you. If you do end up with something like that, this is usually where you have to start throwing some things out that you're never going to use. Maybe some utilities that you don't care about. Maybe you're building a bunch of things with X and you don't need to build them with X, and make sure to turn all those things off to make it smaller. It's not unusual. You'll notice all right, any questions about any of that before I move on? Okay, I'm going to move on. We already did this step earlier by using bitbake layers -add layers, add -layers, and then the name of your layer, which is meta YPDD. Okay. All right. Now we're going to go ahead and bitbake our image, YPDD image. You'll notice that they forgot to put in the -k here, but I'm going to suggest that you use that as muscle memory. You're always going to type bitbake -k. There's no reason not to. It doesn't hurt you. All it does is make sure that it does as much as it possibly can before it quits and dies. You'll notice that if you've already configured the shared state and you've already built something that looks reasonably the same, you'll end up with it taking 5, 10, 15 minutes, depending on how big your big things are. When I'm regressing open embedded, meta open embedded, it takes about 30 minutes because there's about 4,000 packages that it tries to build and goes through. So it takes a little bit of time. Okay. Now, once you've gone ahead and had the image be created, you can go ahead and run QEMU ARM. You can point to the particular version of the output in the temp deploy images directory. You'll notice it's specific by architecture here, and then the latest version image, YPDD image, QEMU ARM ext4, and you'll notice the no graphic if you're using it by coming in through SSH. You don't have to point to it, but it'll look at the latest. If you don't point to a specific image, it'll point to the latest build. So for example, in this particular case, the QEMU ARM would look for the latest build, whatever it is. Let's see now, Vitali. Is it yeah, it is. It's harder. It's actually harder to exclude packages than it is to add packages. We typically use the bottom up methodology. So you build the highest base image that you can, and then start adding packages. The default image is actually just an IMG file. The rootfs image itself, there is no actual targz or any of that. You have to actually create that. It's just a file system within it. You could root into it if it was an x86 and it was completely self-contained. You could do that, but you cannot obviously run ARM on x86. So if you have ARM binaries, it won't work. You'd have to use instead QEMU and QEMU ARM and point towards your actual image. The default is no image. Now, if you want to create an ext4 image, you can create an ext4 image so that it can then be used for the following step, such as you want to go ahead and then apply that in using the WIC tool to put it on an SD card, for example. But the default is nothing. It's just a file system piece. Any other questions before I move on? You're welcome. Did he already talk about what the defaults are for the packaging systems and how the packaging systems work already? And how you can change those to depend on what you want to use? Okay. All right. So the default packaging system that is used in the current releases of Yocto is RPM, but RPM, deb, and IPK are all available to you. You can just simply change that in your local.conf. There's a section within it. You just uncomment the appropriate one, comment the other one, comment the default, and you can create different kinds of packages. It'll use any kind of package that's available, but go ahead and try and choose one at the beginning. Typically that's done, I call it at a policy level, at the site level, as to what you're going to use. Okay, our site's going to always use RPMs, or our site's always going to use debs. Whatever is the decision on that. But just once you do it, stick with it. Generally speaking, it does not look like a binary repository that you'd find at Debian or something else, because it is missing a number of metadata files that pull the index together completely. So you might not be able to just take it and immediately share it back out again as a binary repository. Also, it's a little bit dangerous to do those updates on just a random site. So you might want to think about that. All right, I know that was a divergence. All right. One thing to note is you're trying to find out whether or not remember that we've gone ahead and logged into our QEMU ARM. Our QEMU ARM default is root with no password, just as the default. As far as that goes, we can then find out which version of Dropbear is there. If you use the graphical invocation using BNC Viewer, you'll see the splash screen. So remember, we built psplash over here. The one thing that we added to it was we added psplash. That's our splash screen that hides all the little, hides up what's going on behind the scenes as it boots up. Of course, if you logged in over SSH, you still will see all of that because psplash doesn't suppress that. Excuse me. So you don't change the packaging system to build the init RAMFS. The packaging system is the step before image creation. So as long as you've got the packages in the repository, whether it be whether you've chosen any of the three packaging systems, those will be used to go ahead and create the image during the image creation step. And so hopefully that answers the question. Init RAMFS root system is going to be whatever partition type you have, whatever file system type you have, and then it'll go ahead and boot and run that As long as it's in the kernel and SC file systems, it'll be able to mount it correctly. And yes, that's correct, Vitaly. Okay. All right. All right. So any questions about image files, image recipes, I should say? Remember, when we talk about images here, we're not talking about something that's actually on a physical device, such as an SD card. That's a second step. That's another step which is used to actually take the image file itself that's been created, the image that's been created, and then put that in the appropriate place on whatever device you're going to use it on. For QEMU, it knows where to find it. Yes, you really do need to worry about third-party libraries licenses. Yep. So for example, if you're using the Qt libraries, they're dual licensed, for example, you have to make sure that you have the appropriate license before you include it in your recipe. I don't believe that we're going to cover licenses in this particular course because it's a really quick one. So I don't think we're going to cover that, but yes, you actually have to. Pedro, you could actually go in, and if you know where everything is, you can manually by hand put it right in the right on the device itself, create all the partitions yourself manually, take and copy the kernel into the right place, take and copy DD the bootloader in the appropriate place, go ahead and copy the entire root file system onto that device without using WIC. WIC, however, makes it easy, especially makes it easy to be repeatable. If you use that image size root image size variable, which I rarely people use trsmith, then it would make sure that the image rootfs size is smaller than that. So hopefully that answers your question. LTS, there's only one LTS version currently, Ryan. There'll be another one in April of next year. Yes, April of next year. There'll be a new version of the LTS. So there's only one LTS version. No, Mustafa, images are actually so that you, yes, yes, the answer to your question is yes. There is a way that they are there to image recipes are to modify that in the programmatic way. You can simply add things to local.conf, extra image install variable, and add all the variable pieces that you want, and then eventually turn that into a recipe. But that's the normal way that people do development, is they stuff all the things they want in the local.conf, and then when they're done with that and they say, yep, this is what I want, they take all of those pieces that are in the extra image install, and they go ahead and put them as part of image install plus equals and that whole list. Remember, that is a space delimited list, so be aware of that. If you use that as an append, for example, the first one has to have a space in front of it. Okay. CVEs actually have a BB class. You can inherit that BB class that'll cover CVEs. If you think that a particular recipe has CVEs in it, you can go ahead and inherit that class. You can do it on a system-wide basis by inheriting that class within the local.conf, for example, and it'll run any recipe that you create in any version, and it'll run it against the CVE. Make sure that there are patches there, or if there's not patches, it'll warn you of those kind of things. We showed an example, trsmith, of that back here. Let me show you what it is. Let's see if I can find it. Here it is. Image root fs size equals, right? This is the default. right? It's a default. Question mark equals, it's 8192. So that's how you keep it to where that is smaller than that. Okay, see you tomorrow. All right. No, you don't define that. You'd actually have to figure that out yourself, which one you want TR Smith. You have to figure out which one you want to remove in order to get it. Or you change options. Sometimes you'll change options, and those changing of options will reduce the size. Like, for example, if somehow or other you're building for X and you don't have X, there's no reason to let anything build with X. You can tell it, turn that all off. Yes, there's different image sizes there's different images which you can create, or there'll be different ones. Remember we said that it takes hundreds of gigabytes. One of the reasons why is because we have image files that are older and newer. I don't know how to do a comparison on the CI. I guess the CI could do it. The CI generally doesn't do it. You'd actually do this as a script within that if you need to do the compare. Matter of fact, we do that a lot when we compare signatures and stuff like that. We create a new recipe that sits there and looks at the two different images and it does the comparison. Normally, I'm worried more about comparing signatures and things like that, but you can do that comparison in CI. The CI itself specifically will have a different recipe that does that comparison for you. I can't tell you whether it's supported currently, whether Pocket Tiny is supported currently, as I don't use it myself. I'm if it's still in Hard Knot, if it's still in Hard Knot, then the answer is it's currently being supported. Honister, of course, is coming up. That's the one that's coming up, but currently Hard Knot is the version. Right. Yes, that's correct. It will create FS image types of ext4 and tarbz2. That's correct. And the default Vikram is nothing. Just so you know, it does not have a default image at all. So if you look at that FS image types, it'll be quote, quote. That is the default image. It doesn't create one. It just creates essentially what looks like a file system, and that's it. Just as a tree from the root piece on. It doesn't actually turn it into an actual image at that point. Does that answer your question? Good. All right. All right. All right. So let's talk a little bit about Toaster. Toaster is great because it allows people who are not very comfortable with command lines to be able to actually manipulate bitbake. As long as you've created recipes and all of the layers have been added appropriately, you can go ahead and see what's going on. You can see that somebody's building a core image Sato for QEMU x86, and you can see a rough ETA, although that's probably not perfect, especially if you're running on a remote server. It's very much not perfect. You can see that somebody else is running a core image minimal for QEMU ARM, and you'll see that in each case, they're going ahead and either using it for, this is your target architecture, if you will, or your machine. And specifically, it's the machine. So the first one's QEMU x86, a QEMU ARM. This one's going to be built for an Atom PC. You can see there's different ones. So this core image Sato for an Atom PC, it took about 36 minutes. There were 4 warnings. You can actually go ahead and take a look at those. This x86 version, it took 27 minutes, but had 3 errors. So it basically quit. You can go ahead and look at those as well. Oops, sorry. I forgot this is not a window to do that. You can see a little bit about it. You can take a look at the window, at the warnings, what specifically is going on. You can notice in this particular case, they built an ext3, an ISO, a tarbz2, and an HDD image. You can see if you have failed tasks, you can go ahead and take a look at what the failed tasks are within it. So it's really nice if you're, especially if you're somebody who's not very comfortable with working at the command line all the time and you really want to see what's going on and you want to dig into it. As you saw in the earlier chapter about troubleshooting builds, there is a long path in order to get to where whatever failed. This makes it a little bit easier by clicking on that, figure out what the failed tests are, and you can see exactly what's going on. So that's kind of nice. You can build toaster from scratch. Again, it is a Python app. It requires a whole bunch of other pieces. You go ahead and use the pip3 to do all the installation. You use the toaster requirements.txt, which is found in Pocky Bitbake directory, and then it'll install all the correct pieces. You can then source that OE build environment to the toaster project. Then you go ahead and source toaster start. You got to wait a couple minutes because it takes a while, like every other web server type thing, to gather it all up and make it go and profit, right? No, actually, in order to be able to use it, you'd have to be able to talk to it. It's generally found on port 8000. You can use it remotely if you know the IP address or the URL of the device. Be aware that it doesn't have any concept of security, so putting it on the open internet is probably not a good idea to let somebody muck around with your toaster any more than you'd want somebody to do that on your home toaster. Once you get done, it'll come up and it'll look like this. Now you'll notice in this particular case, it'll show recent builds and things that Toaster knows about. So it'll be able to understand what's going on. There's some log files. There is a Toaster provided manual already. If you're interested in webby type things, you can contribute to Toaster and help them make it better, which is nice. This has been around for quite a while and it continues to be a pretty good tool for, especially for, like I said, for folks who are really uncomfortable spending a whole lot of time. You can create a new build. You can say, this is the machine I want to do. You can say, I want to build this particular one. I want to build core image minimal. And then you click the build button and off it goes. So to create a project test, you're going to use whatever release version you have. Pyro, of course, that's not supported currently. But this is just an example slide. You might want to use Dunfail. You might want to use something later than that. Zeus, whatever you want. So, all right. They didn't have me prepare a toaster thing, and I don't know of any that are online currently that we can get to so that I can show you. We'll go ahead and move on with that. So let's talk about it. Are there any more questions about toaster? Yes, you can configure that in the requirements.txt. You can move it to something else. In requirements.txt, it's where it sets that actual port number to just modify the requirements.txt. No, there's a couple things that go on. Christoph. Specifically, toaster, once you launch something, you can't stop it. It doesn't have that level of being able to do that. And so from that standpoint, it's not a really good CI server. It's probably useful more for somebody who's going to be an applications developer. That's the normal people I have that are using it in work groups. They're much more comfortable with going ahead and they're used to an IDE, and they're going to go ahead and do the development in the IDE, and then they want to go ahead and bake their thing. They'll use Toaster for it. I find it useful also to see what's going on and what people are particularly using. Yeah, you can source the toaster -m. That's correct. That's another way to do it. But I think you can, if you want it to always be on a particular port, I believe that there's in requirements.txt, there's an actual modification that you can do. Yeah, okay. I'm gonna answer that question. Is I can't really give you a good question, Vikram, but I'm gonna tell you where to find it. The mega manual. That's where you'll find that. Go ahead and look at that. I know the image file system types are the ones that are supposed to be output. Image types, I haven't played with very much, and I've never used the typedef live version of it at all. Yep. Any other questions? My understanding is that that has been done, Colin, that people are actually doing that. I have not specifically done that, but I've seen it done I've heard of it being done in Docker. I don't see any reason why it couldn't be done in LXC. Remember that toaster requires you to have the rest of, you know, uh, the rest of the build system in place as well before it can operate. Any other questions? Okay. All right. So now we're going to talk about building applications here. We're going to add this hello world application to your image. And the general way you do this is to create your hello.c, create the recipe that includes the paths of how to build it, modify the image recipe to add your hello. Now we're going to talk about how we normally use a single C application. There's a much more complicated pieces where you need to do other things such as make files or auto make. That's a different style. Okay. All right. Simple C file package, you add the hello application source to a directory called files in the hello package directory. So you'll see your vector. This is meta ypdd recipes core, and we have a hello, and we've got a files as well. So we're using makedir -p to get it all there in the right place. You can go ahead and edit your file. Go ahead and modify it to your heart's content. Go ahead and get it. Once you're done with that, go ahead and save it. And of course, you're going to end up with it being hello 1.0. It would be the next one. So we're going to edit this file as recipe 1.0.bb. And then inside of your recipe file, it would look like this. Here's the description. The license file, well, it doesn't really require a license file at this, but here it is. There's the MIT copying. We're setting the work directory to be the same as your source unpack directory. Your source URI is, I can't see it here, probably because, no, that's an image. I can't see it. But that source URI is actually going to be file : / the path to your hello.c file and hello.c. You're going to create a do compile step and a do install step. You'll notice that you're modifying those because the compiles would actually be done because you don't have an actual make file to tell it how to do the compile piece and how to do the install piece. Let me try something here. It looks to me like I might have a problem with what's going on here. Hold on a minute. Let me just turn this off. Turn this off. Okay. Okay. There we go. All right. Now let me go ahead and present it. It's the first time I run into that. Okay. So you can see in this particular case, hello.c is your file name. We don't have any license file checksums. We don't have any checksums rather because it's a file and it didn't come from somewhere else. Our do compile here, you'll notice passes both C flags and LD flags. Goes ahead and sets what our output file is going to be, what our input is going to be. The install step, again, because we don't have a make file that would normally do this for us, we go ahead and do a manual install step. This particular case, you're replacing the do compile step with this version. And again, the do install step would be replaced with this particular install piece using install, going ahead and setting it up to that goes into the binder correctly. Now the deploy directory binder, and hello. Set up the directory and then set up the actual application and where it goes. Any questions on any of that? This is a simple C file here, once and no make file. Yes, you can change any dir you want to any place you want. You can put it in /opt, for example. That's not unusual to put it there if you want to. You can, instead of saying $bin_dir, which is a normal, which is one of the bitbake variables, you can go ahead and define exactly where you want it to go within that within there. Now, if that directory doesn't exist, right, you have to create it. So you have to create that. If this bin_dir has a special path to it, you're going to have to specify that path and do the appropriate make dir. Only if you've got included files that are part of it. Do you have the file includes? Remember that the recipe would then include a file. It would include a file path for what the includes are, include this, include that, whatever it is. It would then find it within the files dir and files path spec if you have to use either one of those to get it to know where the appropriate place is. Normally it will be in this directory, in the directory that where the recipe is, and the files subdirectory. All right. You could, that's much more complicated to change it to a Qt5 application. And normally it would either have a make file or an auto make associated with it, Vikram. The bin_dir is set initially. What you can tell what it is based upon the bitbake -e of the particular recipe you're doing, as far as that goes, and end. You can find where that is. You can see that within the bitbake -e of the recipe. It'll tell you where it's set. Again, the same thing, Simone, you can find it as far as you can find it in by doing bitbake -e without something if you want to look at the entire bitbake environment and what it defaults to. And for a specific recipe, you'd use bitbake -e and the recipe that you're trying to use. This works on a single recipe, but will not work on things like a package group or like an image recipe. That doesn't generally work very well. Yes, it can be modified. You can tell it where you want it to go and end. Exactly. Bitbake -e, recipe name. Okay. Yeah, all that information is exactly, Ryan. The manual is your source for exactly what it's set for. Okay. If it already exists, you don't need to add anything. Lee, one of the things that's important is that we don't modify anything. We don't add a second reference to the same thing that just restates what the first one is. Only when you modify it do you really need to make a change or add anything to that. Anything else? All right. So after we've gone ahead and created the recipe file itself, we're sure it actually builds and it works the way we want it to build. Then we can go ahead and modify the image recipe itself to add the new hello world. Examples on your next slide here. So here we have a core image for YPDD. We'll notice that the original one is we're going to come from use package group core boot. We're going to use an image install plus equals so that we don't overwrite this image install here, a p splash, drop bear, and now our new hello directory. You'll notice that we need to have a space in between each one of those. We're going to inherit core image so that it actually knows how to build this thing into an actual image. In this case, they've set the root file size to be 8192. That's where you limit it if you need to. You may sit there and limit to a smaller space if that's what you really have. So set that to actually what the actual ext4 that you're going to use is. If it's only 7950, then make sure that you set that for 7950 so you don't assume it's going to be 8192 and realize that this will fit and it won't fit. So just modify that as appropriate based on whatever the file image type that you're using is. Now rebuild your image. The hello file will actually be added to your recipe. The initial step will go ahead and determine when it needs to be done. The parsing step will determine when it needs to be done in the order of the build. Depending on how we parallelize things, it may be built early, it may be built later on. If it doesn't depend on anything, then it might be built fairly early just to get it out of the way. Once you're done, you can go ahead and boot your run QEMU image. You can type in hello, and then you should see it say hello world. Now, this is a pretty typical way of doing development. You'll add your go ahead and add your application, and it could be anything from much more to just a simple file here. You may add something that's not part of any other recipe, but that already uses a make file, in which case you don't have to worry about that. Just go ahead and make sure you get the make file for it in the source code and let it go ahead and build it. If it's auto tools, you have to go ahead and remember to inherit the auto tools class so that it knows to use auto tools for the configuration step. All right. So remember, Pocky and Yocto and Open Embedded are not distributions. They're tools that allow you to create one for you, a custom one for you. So thank you for coming. I figured we've got about 30 minutes left in order to answer any questions. So please feel free to go ahead and ask questions. Okay, yes. If you look at the meta directory, there's a licenses directory in there, and the license file information is in there, Vikram, in the meta directory. Meta licenses, and then you can go ahead and look at there's like 190 something common licenses that are used currently that it knows about. Mustafa, that's where I would add it. I would add it to an application layer and include the layer in BB layers. That's correct. During development, you can certainly put it wherever you want. Go ahead and move it to the appropriate place when it's time. I don't have a slide for that to build the Yocto SDK. You can actually tell it to build the SDK as an image extend. That's generally how you do it. The device tree comes into play. It's built during, it's actually built, Joel, it's actually built during the kernel build, especially if you're using a device such as the, a device such as the, an ARM, for example. Yeah, you could do it that way, Vitaly, if you want to. That's one way to do it, but there's another step. If you use it in the image creation step, you can go ahead and do it that way as well. Yep. It essentially does exactly what Vitaly just showed us here. Any other questions? I have never seen it set up for more than one build machine. It can be set up to actually access a remote build machine itself. So for example, if you have a departmental builder, for example, you can use that. But I've never actually seen it used with more than one build server in the back end. You can go ahead and Bjorn, you can go ahead and add an option where, and basically you're going to tell the make file, it's an OE extra make is what the option is, and you'll go ahead and say dash dash static, for example. You'll pass that to the make file or to autoconf, and then it'll go ahead and build those statically. The tool chain then basically will, the make file will actually pass that on to the tool chain that it's going to be built static. So you do that in the recipe. Actually, I don't know of any, Mustafa, for setting up the documentation, for setting up IDEs, Eclipse, VSC. I'm sure that there probably are, but because I don't generally use one, I don't really know exactly where to find one. But there are, VSC and Eclipse are certainly available. Let's see, 104, slide 104. Let me go back to slide 104 here. I've never tried to do that at all. The Jester, I don't know. I've never tried to do that. Oh, for VS Code, that's good. Mm-hmm. Okay, good. I know people who are using Visual Studio Code and they like it very much for Yocto development. But like I said, I don't set it up myself. Mostly because I'm working on the build servers that are doing the regression stuff, so I don't have to worry with that IDE. Any other questions? Okay, Pedro, I'll get to you in just a minute because yours is a little bit longer and harder question. Metapetalinux is an alternative to Metapaki. No, Metapetalinux, yes, I'm sorry, it is. That is correct, Severin. It is. Ooh, depends on what version you're using. Bjorn, it depends on which version you're using. So I don't understand. Can you be more specific, Pedro, on multiple build servers and what you're trying to accomplish? I would have to, by the way, Severin, I've got to look and see whether Metapetalinux is an OSV layer or it modifies Metapaki. I don't know that. I'll have to look and see which one it is. I don't know exactly where it goes. I haven't used Petalinux personally, so it might be on the OSV layer. Okay, do you need so I think I'm what I'm understanding you're asking me, Pedro, is how do you set up multiple build servers for this? Let me show you what I use personally here, just a second. Let me go ahead and bring up something here. Hold on. I am actually using Jenkins as a build as one. So just let me go ahead and bring that up here. Okay. Okay, hold on. Here. Let me go ahead and stop the share here. Go ahead and share a different screen here, and here it is. Desktop 4. Yep, there we go. All right. So what you're seeing here is my Jenkins server here. My Jenkins server has a number of executors that are all building. I've got 6 builders that are actually building various architectures. So you can see I'm building QEMU ARM 64 MIPS, the RISC processing, as well as QEMU x86 and x86 64. So your CI server can then distribute those images that need to be built to the various servers. And you just make these are build servers, they're nodes, if you will, as part of the build cluster. Does that answer your question? I mean, that's one way to do it. There's other CI servers that would do this as well for you. The Jesser, you want to reconfigure the DTS and rebuild it. Yes, you can go ahead and change the DT source and go ahead and rebuild it. Realize one thing, and that is that it doesn't recognize that that file has changed. So you're going to have to invalidate the stamp and rebuild the whole thing again, so that it also brings in the DTS compiler and goes ahead and recompiles the source for you and puts it in the right place. Yeah, you can do shared state downloads. I do the same thing here with this. I have it on an NFS server for all of them. And since I'm building for different architectures, I use exactly the same shared state cache, because each one of them is talking to its own shared state cache. So depending on what machine a particular build ends up on, whatever architecture, I don't really care, because the shared state cache is available to any of them, to answer your question, Pedro. No, I'm using physical separate builders because I'm building so much. I have 45, typically I have about 45,000 tasks in any particular one. So I'm building in parallel in order to get the speed up. We want to try and do this in about 6 hours from scratch, because we're trying to keep up with master over at from Yocto, or the main line, if you will, at the head. So we're doing that. So anytime there's a change there, we regress meta open embedded against that. Yeah, each one of these builders is 192 gigabytes of RAM, and I'm building in TempFS in order to make that work. So, and generally speaking, I might end up seeing somewhere in the neighborhood of 100 and I don't know, 160 gigs of RAM. Let me go ahead and show something here. Yeah, there it is, right here. Go ahead and show you. Here's what OE looks like. So this is the builds that we're doing right now. Let me go back about 12 hours in the last 24 hours. In the last 24 hours, you can see we've run a number of builds. You see each one of them. You can see the builds here from the individual servers as they work. This is the parse step, and then this is building, because I'm building across all 6 of them. Here, you can see that we use up to 100 gigs of RAM, maybe a little bit more than that. This one used about 120 something gigs of RAM. So it's quite a bit of space. Now this would normally be, would be on a disk drive itself. The actual size of the TempFS, if you will, is about 82 gigs for these builds. So the rest of that was being used is all the RAM that would be used for the operating system and for doing the actual builds. So a typical TempFS for me is around less than 100 gigs. Okay. Yes, it is huge. It's a lot going on. And then we typically see load averages up around 60. Each one of the machines has 24 cores. So it's building in parallel. The, now we've taken to backing things off. And what we found is that when we started backing off the parallelizations, we ended up getting higher throughput because we didn't end up with things being waiting and open to be able to deal with it. So we're using BB threads of 2.5 and minus J of, I believe, 8 is what we're using. It is not, Simone, it only creates the one that you've configured. So if you say I want to use an RPM, it will put output all to RPMs. You find the packages in temp deploy packages or temp deploy, yeah, temp deploy packages. Not able to do that because it contains some information that's proprietary. I can't really do that. Sorry. Okay, I basically what I did was we realized that what we have is 24 cores, and the way we set it up for BB threads of 2.5 and minus J of 8 for that configuration, for our particular configuration. Yeah, there is build, temp, deploy, and then whatever package scheme you're using. That's correct. Did you get the parallelization settings, Pedro? Let's see. We went from going flat out, trying to go flat out, to backing it way off, and we went from an image taking from this recipes taking somewhere around 11 to 12 hours, and we've got it now down to under 7 to do all of this. I'm aiming towards trying to get it to 6 so that we can try and keep up and do 4 builds a day. It's an average, Christoph. It's an average. Right. The build folders are all on tempfs. That's correct. /temp is all setting over there. That's correct. Our downloads directory and our downloads directory and our shared state are on a NFS server with 20 disks running on it. 24 disks on it. It's for every builder that's on NFS. Yes, all of the builders are connected over NFS. Yep. So it's busy. And it really follows the cycles of whatever's going on. So everybody's at the conference right now, so nobody's developing, so there's no changes to where that we have to worry about anything. So that's why it's basically quiet since 0500 today for me, which is noon GMT. So nothing's happened since noon GMT. Builds are very intensive. So if you're using it on a laptop, I'm going to suggest that you lift your laptop up a little bit. You might back off a little bit on the threads. You might back off a little bit on the J number so that you don't overheat your laptop. I don't recommend using a Microsoft Surface for Open Embedded or Yocto at all. Pedro, no. Basically, your NFS overhead's pretty high, and RAM is much tempfs. RAM tempfs is much faster. Yujal, you shouldn't have the same recipe in multiple layers. You should append them. So if you want to go ahead and do an append, you shouldn't have an actual version unless if it's the same. The same in this particular case would be the same version number. So the fact that it has the same name, package name, isn't the same thing as having the same package name version. If it's the same package name version, you should be appending it if you have to make modifications and not carrying forward the same version that's found in another layer. If you do have ones that are in another layer, delete all of them and just do an append. Does that answer your question? Good. Pedro, you're asking about these spikes right here. These are NFS RPC calls. This is me. This is at the beginning. You'll see that they're starting at the beginning and the ends. They're starting the cycle. And when they do, the first thing they're doing is they're accessing the shared state cache, and they're trying to find out what's available there so that it knows what's going on during the parse step. How long do those actual spikes take? They're not very long. They're on the order of a couple minutes. They're like 4 or 5 minutes worth of work there. Yep. Not very long, but they are intense. You'll notice that I staggered them. The one thing I did was we used to launch them all at the same time, and that was really not good. That was really, really not good because basically we were slamming the server. So I went ahead and did 3 groups of 2. You want to speed up that step, throw more RAM and throw higher amounts of CPU at it. Remember that step is the most intense step, the parse step. The step that takes the longest in every recipe is configure. If you want to speed up that particular step, you clean state. Yeah, basically, I usually throw it away when we run out of space. That's correct. Unfortunately, because I have a 10 terabyte space, it takes a long time to delete it. So it takes a long time. I try and do it about once every month because I'm doing regressions. I do not throw the downloads directory away. Usually other people will come to me and say, hey, this is gone. Would you put it in your mirror? They'll give me a copy of they'll give me the source code. They'll give me an MD5 and a SHA-256. I'll go ahead and put that in the repository, and then it'll become part of our mirror. Either at Michael Halstead will do that for his group, or I'll do it for OE, depending on which source it's for. Any good reason to clean share state? Yes, it gets huge. The other reason for doing it is to make sure that things actually build, because sometimes you'll say, oh, well, it's in there already. And then you find out later on that the build is now broken for other people because they don't have the same shared state as you. So clearing the shared state out or using the -- no set scene option will go ahead and create a build that does not use shared state, in which case at that point you can find all these things, all these problems that have crept in while you've been happily saying it works fine. -- no - set scene, all one word, SET, SCE, and NE. Lay, that's hard. One thing to do, maybe to speed it up, would be to turn down some of the parallelizations options. That'll definitely not make it so that you need a whole lot of additional space. That helps a lot. By not having the parallelization set so high, it means that you're not expecting to have a lot of things open that are waiting for other things to be built. So I suggest that you might turn down the parallelization a lot. You might say BB threads is 1 or 2, and you might say parallelization is either off or something else. Well, I can't say because it depends on what image you're actually going to put on there. There's people who there's people who actually use init ramfs's only, and they're 100 megs, 200 megs. I've seen this. That's kind of the smallest I've ever seen. But the actual sizes of a real file system depends on what you include in it. What I suggest is that you look at the actual file system, especially if you told it you want it to be an ext4 image or whatever it is you want. You may sit there and say, well, okay, how big is the stuff that I just built? And it'll be in temp deploy images, and you could actually find out what the size of it is there. Lay, did I answer your question? Okay, Vikram, I missed your, I know you asked me that question. In Jenkins slaves, all we can, what all can we share in NFS? I generally share the downloads directory, and I share the shared state cache. Those are the only two things that I generally share for this in the Jenkins slaves. I try and do everything else locally. I do have some additional space that I've added to some of the devices just to play with some things. Most of the time, I'm using the rest of it's in tempfs just to speed things up. Did that answer your question, Vikram? Okay, good. All right. Lay, the reason why is because you've got limited space. What happens is that BitBake will have a whole bunch of files that are open and waiting for something to happen. If you go ahead and make sure that you've finished building a files or finished building a particular recipe and then move on to the next recipe, you don't have a whole bunch of things open. It doesn't increase the amount of RAM that you need. It reduces the amount of tempfs that you have to use in order to, the builds, and it increases the speed because of that. Really what it comes down to is if you turn up the parallelization too much, you'll end up with too much context switching, in which case the CPU is doing nothing but context switching just to try and keep track of what's going on. So by reducing the amount of parallelism, you reduce the amount of problems with context switching in smaller systems, especially, or in systems that are RAM bound or CPU bound. It solves that problem for you. It doesn't solve it, but it lessens it, I should say. So yes, turning down the parallelism. I'll give you an example. On these machines here that I was just showing you, turning down the parallelism gave me about a 50% boost in speed, simply because there wasn't all this context switching going on. If you Pedro, if you successfully bitbake the package and it's already in the repository and it shows up in shared state cache, the answer is yes. It will be already available for the full build if you run it later. That's correct. Yes, you can build it in different versions in the same versions in the same build. That's correct. Now you're going to have to figure out how to explicitly call the specific versions, though, right? You might have to actually put the path and use something like an preferred. Well, they don't have the concept of alternatives in bitbake stuff, but you could do that. This is done with Ruby, for example, and Ruby gems. I see that a lot. You're welcome, Pedro. You're welcome, Anand. Any other questions? Very good, Daniel. Thank you. I only have used R recommends. I've never used bad recommendations. Ever. Yep. I'm not sure I have that available really. That CI/CD setup is a little specific to our hardware and setup. I'm not sure how I can unwind that for you there. I don't know. I'd have to talk to some my other partner on this and see what he thinks about how I would be able to extract that and anonymize it enough. Yeah, I don't really have that because this is probably represents 6 or 7 years worth of doing it, so I don't have anything that's really fresh. I could think about that. I don't really have a particularly good. I don't know if he put our email addresses up there or not at the beginning in the slides or not. I don't remember. You could always try and go back through the Yocto Project folks, and they can get a hold of either BN or myself that way. Okay. All right. Thank you, Shalom. You can ask them about it. By the way, they will probably tell you about their Yocto Auto Builder, which is great, and of course is Python. So be aware that they have the Auto Builder as a sub project, so you could use that for sure. Yeah, the recording is coming. They'll be editing it, and once they're done, they'll go ahead and post that. And again, watch the Octo folks and the Octo channels and the website for that. Okay. Thank you. Mhm. All right. Okay. Good. I'm glad that the CI section helped a lot. One of the things that Yocto is designed specifically for is doing CI very well, and it does, because you can easily integrate it in as part of your process. Matter of fact, if you're doing work groups, I recommend that you go ahead and have the auto builder build things for you overnight so that the next day you can all grab a shiny, fresh new version of the shared state. Okay. Are there any other questions? Okay, I'll be right back in just 1 minute, please. Yeah, that's the way a lot of the places that I work at do that, Christoph. They use a nightly build shared state and then go ahead and use that as their starting place. It keeps everybody on the same page, allows them to work against it. Um, it's especially good if you're trying to work on the same architecture because that becomes a little bit of a thing. You don't want somebody changing out from underneath you. Um, a library that you're working on in the shared state, it may build the first time and doesn't build the second time, and it's like, why did this break? And I didn't do anything that should have caused this to break. It theoretically should work, but I'm not too happy with that. Like I said, I'm building with the same shared state. However, I have different architectures that are all building in parallel, and so there's no conflict. The only one that you have to worry about is the no arch, if you will, things like documentation and other pieces like that. For that, typically when I start over again from the beginning, I'll go ahead and kick off one of the servers to build initially, let's say QEMU ARM x86 or QEMU x86 rather, will be the one that I'll build. It'll go ahead and build all of those no arch pieces for me ahead of time so that there's no competition. And then it continues on with the build. And then I start the rest of the build cluster and let it go. That solves that potential conflict there. You don't want them trying to build the same thing at the same time and trying to thrash the shared state cache. All right, I want to thank everybody for coming to our sessions today. Hopefully they were helpful in getting you up the curve a little bit in starting with the Yocto project. There's an additional training available in different places, including the Linux Foundation itself, of course, the IRC channels, and the mailing lists are all available to you. There's a whole bunch of communications channels that work very well. Please avail yourself of those, and I look forward to seeing you be successful in all your projects.